Bismillah, Assalamualaikum warahmatullahi wabarakatuh. So today we will be dealing with equilibrium of rigid bodies, specifically 3D problems, right? So we will be dealing with 3D objects today, 3D structure, three-dimensional structures, inshallah. Right, so in the past tutorials we have covered how to draw the free body diagram, including for 3D, as well as how to solve equilibrium problem for two-dimensional structure, right? So the difference between 2D and 3D is basically in 2D we only have x and y axis, in 3D we have x, y, z, right? And in terms of the equation of equilibrium, instead of just fx, fy and moment, which is 3 equation for 2D, we have 6 equation where fx, fy, fz, mx, my, mz, right? So it involves a bit more number of equations, hence a possibility of a longer calculation because of simultaneous equation, as well as you need to understand all the support reactions in 3D, right? So hopefully you have covered the lecture. Before coming to the tutorial, we have discussed how to understand support reactions in the lecture. So if you haven't, we will not discuss on the theory in this tutorial. We will just apply, right? So hopefully you have watched the lecture first in terms of understanding how to understand support reactions, right? So this is important to draw the free body diagram and then solving the problem, right? So if we have covered, if you get the free body diagram wrong, then the whole calculation will be affected, because you will actually calculate based on your free body diagram. If you identify wrong forces or moment in the support reactions, for example, the calculation will be affected, right? So hopefully you have understand those part first before going to this tutorial, right? So as usual, we will cover exam question, be it of course for chapter 5 it is from the final exam of the past several years of examination questions. So I picked up all the question related to 3D equilibrium of rigid body problem, right? So inshallah, so if you need to take a look at the questions that we will be covering for today, the PDF is in the description box below. You can download it. If you want to select, because this video might be long for this today, because there are actually a lot of questions from the past exam for this particular topic, right? 3D equilibrium of rigid bodies, right? So there's a lot of question, and each question can be longer than any question before. So this video might be a bit long, perhaps, I'm not sure yet, but it might be. So if you have limited time, you can download the PDF of the questions, see which question you want to go through the tutorial about, and then just go to the timeline. So you just select which question you want to watch and try and practice, right? So that's another thing. I do suggest that you do solve throughout the tutorial, go about trying to solve while we are going through the tutorial, at least, so that you actually test your mind whether you actually understand what you need to do when you face such problems. All right, so having said that, inshallah, we will go straight into question number 1. All right, so as you can see here, the question on the left, you have the structure. You have some sort of a pipe there, and then you have the ball and socket, and then 2 cables there, and some distributed loadings there. So the question have 4 parts here, A, B, C, D. So we'll read the question first. Part A, draw the free body diagram necessary for solving all the support reactions at ball and socket joint A and the supporting cables DB and DC. Distributed loads should be transformed into single point loads in the free body diagram. Alright, so the first question is about free body diagram, and we need to understand all of those to be able to move on to the next part, right? Part B, express forces in cables DB and DC as Cartesian vectors. Part C, determine the components of reactions at the ball and socket joint A and the tension in supporting cables DB and DC. And D, can the support reaction be determined if the ball and socket joint A is replaced by a fixed support? What is the reason? Alright, so Actually, this question, when it comes in the final exam at that semester, why the question is structured as such, because many students actually struggle in the midterm. Hence, the question in the final is designed to actually help a bit the students, right? So that's why it gives stages by stages by stages, so the student can actually be guided, or first draw the free body diagram and then express the forces in Cartesian vector form and then solving, right? So and we will see question after this, right, in other questions where the question is not given as such. The question can be given straightway, find the support reaction, right? And you need to know yourself, you need to draw the free body diagram, you need to express the forces in Cartesian vector form, right? But in this final exam, in that semester, the student actually struggle a lot. In the midterm, the mark is quite terrible, so the question is designed to very much help the students to know what to do step by step, right? Hence the question is like that. So I'm just explaining this so that you know as we go on to different type of question, why the way the question is given quite different, right? Anyway, so the first step is to draw the free body diagram. Alright, so in the two tutorial before this, right, so we have actually gone through how to draw the free body diagram for each of these, right? So I will not explain too much here because I assume you have understand that already from the previous tutorial. So we'll just go about it, right? So basically you have the structure, so you have the axis X, Y and Z, something like that, and then the structure itself, right? So you have something like that, right? So this is point A, this is point D, and the rest, right? Okay, so that's the structure. So in terms of free body diagram, hopefully you have understood already. Hopefully this is clear, right? The size is hopefully okay. Hopefully you already understand that what constitute a free body diagram, right? So you have to have the outline of the body, so you have there, and then you have to have the forces, right? So we'll start with the easiest one first. So here you have two tension there, right, from the cables. Again, free body diagram means it's free from the surrounding, so you should not draw the cable, you should not draw the if you look at there, you should not draw the whatever is point B or point C. That should not be in the picture, right? So it should be free from those, and we replace with the corresponding forces, right? So these forces, and then the distributed loading here, we have to turn into a single point load there, and then we have the support reaction at A, right? So given this is a ball and socket, so what is the axis? So this is X axis, maybe this is too long, this is Y axis, and this is Z axis, right? So we have AX, AY, AZ, right? So you have, it seems too small, right? Hopefully it's not too small when you see this in the video. All right, so we have the support reaction AX, AY, AZ. This is for ball and socket. The two tension. Okay, so for every known force we have to put the number, every unknown we have to put the label, right? So that's, if you miss all of any of those, you will miss the mark for the free body diagram, right? So we have labeled this one we have to label as well. So let's say FDC, for example, and FDB, and then this one we should know the value, right? So it is 800 Newton meter. So in terms of the calculation for this one, it is 800 Newton per meter with a distance of 3 meter. So we'll get 2400 Newton, right? 2400 Newton. Is this a complete free body diagram? Something is missing, which is the dimensions, right? So any dimension that should be included must be included. So let's say, so for this one, for the distance d, right? So we have, okay, we have 1 meter here, where the height is as well 1 meter, and then this distance here we have, this should be at the middle, so 1.5, but the whole distance is 1.5 plus 1.5, 3 plus 1, 4. So this is 4 meter. The height is 2.5, right? So the height is 2.5 meter. Right, so hopefully you can see the difference in color, right? Because I have the luxury of having different color of marker. So in your exam, if you use only one color for all, make sure the way you draw is easily understood, right? Make sure also differentiate between forces and axis, right? For the axis we do not draw any arrow, but forces we have, right? So make sure that is clear, because if you draw an arrow here, it will be confusing. Is this force or not, right? So make sure all those tiny details, because it becomes big in the exam, because we want to understand, right? Okay, so that is basically the free body diagram. In terms of this question, we already solved part A. This is the answer for part A. If you have all the elements, the body itself, free from the surrounding, all the forces, all the unknown is labeled properly, all the known, the number is here, all the dimensions, that will give you full mark for free body diagram. Alright, part B, express dB and dC, the force dB and dC in Cartesian vector, right? So that's the second part. So going straight to that, so for FDB in this side, right? So basically from D to B, so the coordinate of D is 1, 0, 1, right? 1, 0, 1, right? B is what? 0, negative 2, 3. Oops. 0, negative 2, 3, right? Alright, so from here RdB is this minus this one, so minus 1i minus 2j plus 2k, right? This is 3 minus 1 equals 2j. Okay, so RdB is square root of this square. I'm not writing in full, but I think you know what is inside, right? So you have to write inside. So from here is what? 4, 1, 9, 3, right? So you get 3. In terms of unit, this is meter, right? And then unit vector dB, unit vector dB, so this divided by this one, so minus 1 over 3i minus 2 over 3j plus 2 over 3k. So FdB is just F, the magnitude times this unit vector. So minus 1 over 3 FdBi minus 2 over 3 FdBj plus 2 over 3 FdBk. Alright, so that is, you already expressed FdB in Cartesian vector form. What about FdC? So for FdC, so it's basically something like this. DC, so for point D is the same, right? So 1, 0, 1, 1, 0, 1. Okay, point C is what is it? 0, 0, 2, 3, 2, 3. Right, 0, 2, 3. Okay, so RdC, this minus 1, so minus 1i plus 2j plus 2k. It's similar, is it? Except for this one, right? So one is positive j, one is negative j, right? So RdC, the magnitude is from 3. Of course, this is meter, this meter. So UdC is, this is divided by this, so minus 1 over 3i plus 2 over 3j plus 2 over 3 K. So FDC will be just this multiplied by magnitude of FDC. So minus 1 over 3 FDCI plus 2 over 3 FDCJ plus 2 over 3 FDCK. Alright, so we have established part B, where you have to express forces, these two forces, in Cartesian vector form, right? So this is in Cartesian vector form, this is in Cartesian vector form. Alright, so going to part C. Determine the component of reactions at the ball and socket joint A, meaning we need to determine what is AX, AY, AZ, and also what is the supporting force, which is FDC and FDB, right? So what do we need to do? So we know this is equilibrium problem, right? So for equilibrium, so both have to be satisfied. Summation of forces should be equal to 0. Summation of moment should be equal to 0. Right? Can you see that writing there? Hopefully you can. We have limited space here, so hopefully you can still see the writings there. Hopefully, inshallah. I try to bring it close as much as possible. Alright. So which one do we want to do first? If we use forces, then we cannot solve straight away, right? Because all the forces are unknown here. So let's do moment, right? So if we take summation of moment about point A equal to 0 in vector form, about point A, and hopefully by now you have understand the logic why we select the point like this, right? Because at this point, this and this will give 0 moment, hence this will not be an equation, hence we have limited unknown, hence we can solve basically, right? So in other words, summation of all R cross F equal to 0, right? So this is where it is quite clear that to solve chapter 5 you have to really understand chapter 4. If you are still struggling how to understand summation of moment, how to understand moment about a point, how to understand things like that, meaning this chapter require all those knowledge that you can just use at your fingertips, right? So that is crucial. If you have any problem still with chapter 4 about understanding moment about a point, etc., make sure you resolve that as soon as possible. Now, solve it now. Do not delay, because that need to be understood first before you can actually go through with all of this, right? So do not delay at all. I'm really suggesting you not delay at all. It is for your own benefit, right? Because we will go to chapters and chapters and chapters where chapter 4 is the fundamental that you have to really have solid foundation there. Alright, moving on. So meaning R cross F. So we have to calculate R cross F for everything. We do summation, it will be equal to 0, right? So in other words, if we have this one that the R is 0, right? So no moment there. We have this one will have R cross F, this one R cross F, and this one R cross F as well. So if I do one by one, it means what? This means what? R from A to D cross F dB, that's one moment, right? Moment by this dB about point A. This is calculation about a point, right? So moment produced by FdB about point A. So RAD and then FdB. And then what about this force? So RAD cross FDC, right? So moment about this point by this force is RAD cross this force. And then moment about this one is plus R, how to label that? Let's see, RAF, if this is F, right? So R from A to F, and then cross with F, what is this? 2400, right? Just label it something, equal to 0. Okay, we have limited space, seriously. Alright, so R cross F for this one, R cross F for this one, R cross F for this one. Summation of all should equal to 0. Right. So we know how to solve this one already, right? By using the matrix. So for this one, I, J, K, RAD is 101, right? 101, right? Force, we already expressed here, FDB, right? So just bring it inside. So minus 1 over 3, minus 1 over 3 FDB. Okay, this will be quite small because of the space. Hopefully you can see. Minus 2 over 3, minus 2 over 3 FDB, plus 2 over 3, plus 2 over 3 FDB. Okay, I hope this is not too small, right? Okay, but if you are trying as we go on, I think you can follow, right, where all of this come from, etc. Right? So plus I, J, K, 101 is the same RAD, and then this force here, right? So minus 1 over 3 FDC plus 2 over 3 FDC plus 2 over 3 FDC. This is the second matrix. Okay, we are running out of space. Okay, plus I, J, K. This is very tight space here. So okay, what is this RA to this force? So X is 4, right? This is 4, and then going up 2.5. So 4, 0, 2.5. 4, 0, 2.5, right? Okay. And then what is the force? Is straight with downward. So 0, 0 minus 2400, right? Minus 2400. Okay, all of this, okay, not enough space over here, equal to 0, right? All of this equal to 0. And then we just do what we have done before, right? Solving each of this to get the equation, right? So for this one, wow, the space. Okay, I'm using different color. Hopefully it's clear, it's a different color. So that you can differentiate between this line here, right? Because, okay, so for this one, so you know what to do, right? Okay, 0 minus, this one minus, minus plus, so 2 over 3 FDB, right? Alright, minus J, so 2 over 3 FDB minus plus 1 over 3 FDB, right? Plus K, so this minus, so minus 2 over 3 FDB, right? That's for this one. What about this one? So plus I, so minus 2 over 3 FDC. Okay, I made a mistake there, so I should have brought it down a bit. But anyway, okay, minus, minus 2 over 3. So minus J, 2 over 3 FDC, minus plus 1 over 3 FDC, plus K, where is it? Okay, 2 over 3 FDC. And then this one, plus I, 0, that 0 and 0, minus J, so what's 4 times 2, 400? So 9600, is it? 9600, negative 9600, I believe, right? Plus K00. All of this equal to 0, right? All of this equation, the long equation, equal to 0, right? So, and then if you already established this one, then you can straight away say, okay, this is I component, J component, K component, right? So it makes us easy, right? So let's say from here, if you do summation of mx equal to 0, meaning you take this line, right? So meaning that you'll have 2 over 3 f db minus 2 over 3 f dc equal to 0, right? Or if you take this mz, summation of mz equal to 0, so you'll get minus 2 over 3 f db plus 2 over 3 f dc equal to 0. From here, either one, because it will give you the same thing. What do you get in the end? If you decalculate, you'll get f db equal to f dc. Okay, because when you bring it there and then you cross, so both will give you f db equal to f dc, right? So now we're getting somewhere. Then we can use this for summation of moment about y, right? So until this point, of course, I think you have understand this already, and we don't need this anymore. We just want to calculate this. Do we need this? Okay, we need this because we want to refer to this forces, right? So but with this one is okay. Okay, I will use, because we are short of space here, right? So I will use just the force, because we need the force to calculate further, even though you have on your paper, but I don't. So I just want to remain that one. Okay, so we have all these forces expressed already, and the moment already, right? Okay, so from this already established, so we can use to do summation of my, right? So summation of my equal to 0. So we take this one. So okay, this one becomes what? 2 over 3 plus 1 over 3 becomes 3 over 3 becomes f db, right? So but you have minus there, so minus f db. So this 2 over 3 plus 1 over 3, 3 over 3 is 1, so minus f dc, negative plus, so plus 960 equal to 0, right? Of course we know this is equal to each other, so you can just replace and you can bring out there. So what you get is basically 2f db equal to 9600, right? Or f db equal to divide by 2 is what? 4800. This is in Newton, right? Because it equals, so of course f dc as well is 4800 Newton. So we already have solved two things. One is f db, one is f dc, right? Alright, so we have covered the two forces of the cable. Right now we need to calculate for ax, ay and az, right? So we have used all of this summation of moment, right? This summation of moment we have completely used, so I can erase that one, inshallah. I can erase this one. We can, because what we haven't used yet is summation of forces equal to 0, right? This one, summation of forces. This is summation of moment, so I will erase this one. So moving on to summation of forces equal to 0, right? So we can start with summation of fx, for example. So summation of fx equal to 0. So we add all the x component, right? So here we have ax, and then for each of these we have the x component. For db we have here the x component, so minus 1 over 3 fdb. Fdb is 4800, right? Okay, and then for fdc is this one, so minus 1 over 3 4800. This one doesn't have any x component, it's only going down, so this equal to 0, right? So from here you can calculate ax equal to, what is it? If you calculate, I think 3200, is it? Right. Do verify all the answer in case I did make a mistake, right? So hopefully I told, but in case if I do, please notify so that we can correct it. Please check in the comment section below if anyone corrected anything yet, right? So hopefully this is correct. Okay, so summation of fy equal to 0, so we add all the y components. So here we have ay For these two, we have y component as well. So here, minus 2 over 3 for 8, 0, 0. And then this one plus 2 over 3 for 8, 0, 0. This one doesn't have y component, so it will equal to 0 here. Well, this one actually cancel each other, right? So we have a y equal to 0. Right? Is it logical? Sometimes you just have to think to yourself, is it logical? It is if these two is the same, right? So because these two have the same thing and the direction is just opposite to each other, so it cancels each other, so there's no other forces in y component, hence this will be 0 to keep it equilibrium, right? Summation of fz summation of fz equal to 0. So we have az over here. For this one is plus 2 over 3 4800, right? And then plus 2 over 3 4800, and then minus 2400 equal to 0. Right, from here you can, why should I do that? Okay, so AZ you can calculate, right? What do you get? 32326844, right? For 4,000, is it? 3232 for 3232 6004 minus 24 4,000. Bring over that side, negative 4,000, right? What does this negative mean? It is actually downwards. And is it logical? Yeah, because if this is big, force upwards, this one is smaller, force downwards, so this have to counter another downwards to keep it in equilibrium, right? So basically you will have that one. Of course, when you have negative answer, normally it is expected that you explain something, right? So this is downwards, just to illustrate that you understand what it means, because forces can never be negative force, right? What does it mean, negative force? It's only meaning in terms of direction, right? So it's not upwards, so it's downwards. And again, I did mention about drawing your free body diagram in the previous tutorial. Always, this is suggested. Always put everything in positive direction. AZ, AX, AY, so that anything become negative, it's quite clearly it's the opposite direction. If you mix up, right? So this one you draw downwards, this one you draw negative, etc. It will be confusing because when it's positive, it's actually downwards. When it's become negative, it's actually what, right? So it's hard to follow, especially for the examiner. So avoid making headache for the examiner, right? Because it can affect your marks, consciously or subconsciously or something, right? Anyway, so that's the question number 1. Okay, we have another part. This is part C, right? We have solved these two forces and these 3 supporting reaction, right? And that's part D there. Can the support reaction be determined if the ball and socket joint A is replaced by a fixed support? What is the reason, right? So maybe we'll just reintroduce the diagram there. Hopefully I remember to put the diagram back. So at point A is ball and socket. The question says, what if you replace that ball and socket with a fixed support? Can you still determine the support, right? Support reaction. Now, the question is related to this. If that point A is no longer ball and socket, but is fixed, what will happen here? We will have another 3 moment, right? So this one is MAY, MAX, MAZ, right? So when you have fixed support, you have 3 force, 3 moment here, and then you still have these 2 unknown here. So the total number of unknown becomes 8, but the equation you have only 6, right? Only 6 for this one, 3 and 3, right? So meaning that it is statically indeterminate. You cannot solve, you cannot determine the support reaction, right? So that's basically the explanation and the answer. Normally the question is what is the reason? You have to provide the reason, right? So there's number of when you have fixed, you have this, then the number of unknown in total, it becomes 8. So 8 is more than 6 equation that we have. Hence, so the reasoning must be there, because normally the mark is on the reasoning, because for you can just guess yes or no, right? But that the mark will not come from there. The mark from what is the reason. All right. Hopefully that is clear. So we go on to the question number 2, inshallah. All right. This is question number 2. You can see the structure on the left there and the question on the right. And so the question says the pipe assembly supports the vertical load as shown in the figure. Determine the components of reaction at the ball and socket joint A and the tension in supporting cables BC and BD. Right, so if you look at the diagram there, it is very similar to what we have covered in question number 1, right? So it's indeed very similar, except for in question number 1, if you notice, you have the distributed loading given. Here you just have some single point force load there, right? So that's the only difference. Otherwise, you have the cables and you have the ball and socket. So you will see that the solution is very similar for this question compared to question number 1. Now, if you think that, okay, then I already understand question number 1, just looking at this, I can already do this in my sleep, so I don't need to cover this. Feel free to skip to question number 3. Don't, it's no problem, right? So if you need to just practice even more, try to do it and just compare with what we are doing in here, and just making sure that you understand everything. You can go through this question as well. But if you think, okay, this is just the same, I fully understand it already, feel free to skip to question number 3. Otherwise, we'll go on, right? Again, the steps are the same. It is basically something like that, X, Y, and Z. So in terms of the structure, of course the structure lies on a different axis, right? So that's perhaps a different right. So it's on the YZ plane right now, right? So what else? So we have the structure and the forces. So you have forces, one here, one there, and then you have forces here and forces here, or force rather. This is 3 kilonewton, this is 4 kilonewton, this is FBC, FBC, FBD. Alright, this is, of course, this is another ball and socket. So you have AX, AY, AZ. Again, we assume everything in positive direction. Right, so that is the free body diagram. Of course, in terms of the dimensions, so what do you have? So here is 2 meter and going up 2 meter, right? For that 3, so that's okay. This 3 is half of 6, so this is 3, but plus 3 is 6, 8, right? So how to do this? Okay, this one is 8 meter, and the rest is 6, 9, 10, 11. This one is actually 11 meter, right? From that distance there. Correct. 2, 5, 6, 7, 8, and then 5, 11. Alright. So, and this height is 5 meter. Alright, so that's basically all the body itself, the load, the known, unknown, all the labels, and all the dimensions. Right. So again, this question, how it is different than question number 1 is that question number 1 actually give you A, B, C, D step by step. Right? Draw the free body diagram, get the force in Cartesian vector form, right? But here you don't have that step by step. You have to know that is part of the solution that you have to provide. Draw the free body diagram. Get this in Cartesian vector form, right? So step by step you have to show as well, right? So let's go. So for FBC, So it's basically something like this, right? B, C. So B is okay, X. Okay, this is X is 0 to 2, right? This B. Point C is 4, 0, 6. 4, 0, 6, right? Okay, so RBC is this minus this one. For I minus 2J, what is this? Plus 4K, right? 4 minus 0, 4, 0 minus 2, negative 2, 6 minus 2, 4. Alright, so RBC equal to square root of everything equal to, what do you have here? 4 becomes 16, 16, 16, 16 is 32, 36, right? 36 square root 6, is it? Right, is it? Yeah. Okay, so UBC, so divide this, so 2 over 3 I minus 1 over 3 J plus 2 over 3 K. And then FBC is 2 over 3 FBCI minus 1 over 3 FBCJ plus 2 over 3 FBCK. Alright, hopefully it is clear. Alright, that is for FBC in Cartesian vector form. So we do the same for FBD. Now, as you can see from now, for now, at least that question and this question, right? There's a lot of steps that you have to cover. And all of this, it is expected that it doesn't have any too much thinking time. You know already. Just do step. Just calculate, right? So if in the exam you are so unprepared, or right now when you are so unprepared, how to do this? If you're taking too much time, you are really unprepared for the exam. Make sure you polish on that, right? Understand how to get to the correct answer and understand how to do it in the optimum time, right? So that requires practice. Okay, anyway, so this BD, B is the same, 0 to 2. D is minus 4, is it? Minus 4, 0, 6. 6 upward, right? Minus 4, 0, 6. Alright. So RBD is just this minus, so minus 4I minus 2J plus 4K. RBD, the magnitude should be the same, right? So yep, UBD minus 2 over 3I minus 1 over 3J plus 2 over 3K. FBD is minus 2 over 3 FBDI minus 1 over 3 FBDJ plus 2 over 3 FBDK. Alright, so we have expressed the two forces in Cartesian vector form. Why do we need to do this? Actually, it's making it easy to get the XYZ component later on, right? So it's not compulsory to turn everything into Cartesian vector form actually, right? So, but if you if your way is very unstructured and it's very hard to follow, how do you get that X component, how to get Y component, the examiner cannot follow and it will be affecting your marks, right, in terms of the exam especially. Alright, so that's the Cartesian vector form. The rest is just how to solve equation of equilibrium, right? So for equilibrium, summation of forces have to be equal to 0, summation of moment equal to 0, right? Right. So again, because this have all x, y, z component and then x, y, z component, so we need to use moment first to solve, right? So summation of moment equal to 0. So we'll take moment about point A. So summation of moment about point A equal to 0. So summation of R cross F must be equal to 0, right? Because we don't have any couple moments, so all is R cross F. So this time around, I'll straightway go into the matrix, right? Because hopefully you understand what we do. Right now we have R cross F for this, R cross F for that, R cross F for this, R cross F for that. So we have 4 matrices. Hopefully you have enough space. So I, J, K. Let's start for FBC. So A will be from R from A to point B here. So 0 to 2. And then the force is this one, right? 2 over 3 FBC minus 1 over 3 FBC plus 2 over 3 FBC. 2 over 3 FBC. I'm sorry if it's becoming so tiny because I want to cram everything in this space, right? So, okay. Plus I, J, K, and then still are the same, 0 to 2, and then F is this one, right? So minus 2 over 3 F, B, D, minus 1 over 3, minus 1 over 3 F, B, D, 2 over 3 F, B, D. 2 over 3 F, B, D. Okay. Evidently not enough space, so I have to put down there anyway. Okay. Plus I, J, K for this one, 3 kilonewton, right? So it is 0.85, right? 0.85. Correct? 0.85. 5, right? And then 3 downward, right? So 0, 0 minus 3. What about this 4? So another matrix, I, J, K. Okay, 0, 11, 5, 0, 0, 8, sorry, yeah, 0, 11, 5, right? 0, 11, 5, and then 0, 0 minus 4. All of this equal to 0, right? All of this equal to 0. So writing down here, right? From here I'll use blue. Okay, the lighting is can you still see? Okay. All right, for this one, for the first matrix, so we have I, this minus this one, right? So this becomes, what is this? 4 over 3, 4 over 3 F, B, C, minus become plus 2 over 3 F, B, C, right? 4 over 3 plus 2 over 3, okay, minus J, 0, so minus 4 over 3 F, B, C, plus K, so 0 minus 4 over 3 F, B, C. All right, so that comes from the first matrix. Going to the second matrix, so plus I, so 4 over 3 F, B, D, minus plus 2 over 3 F, B, D. Okay, minus J, 0, then minus minus plus 4 over 3 FBD plus K, 0 minus 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 plus 4 over 3 FBD. For the third matrix here, plus I, so minus 24, is it? Minus 24 minus 0, right? So minus J 0 0 plus K 0 0, right? And then for this one, plus I, so minus 44, right? Minus 44, okay. Minus J 0 0 plus K 0 0, right? All of this equal to 0. All of this, right? Okay, right now, so you have moment X, moment Y, and moment Z already expressed, right? So we can go and use that one, right? So can we make use of anything? Because this one is having many things. So this one, okay. So let's go for this one first, right? So summation of moment Y equal to 0, meaning this J component. So minus minus become positive 4 over 3 FBC minus minus plus, this is minus, right? Minus F and minus 4 over 3 FBD equal to 0, right? Or if you take summation of moment Z as well, what you have is minus 4 over 3 FBC plus 4 over 3 FBD equal to 0. So from here, you'll see again this is similar to question number 1 just now. Both of this will give you FBC equal to FBD, right? And yeah, because it's the same type of question where these two actually is symmetrical. Yeah, sorry, I forgot the word. It's basically symmetrical in the different direction, right? So you'll get this one, right? So all right, so you have established this one. So with this is equal, so you can solve for for mx, right? To solve for both of these. So I will erase this part here. So having obtained this one, so we can continue. I'll still continue with the blue marker with this mx, right? So summation of mx equal to 0. So what we have here is 4 over 3 plus 2 over 3 becomes 6 over 3, basically becomes 2 FBC plus 4 over 3 plus 2 over 3, 6 over 3 becomes 2 also, plus 2 FBD, and then minus 24 minus 44 should equal to 0, right? That's straight away from here. Of course, given that this equal, so we can just plug in, so this equal to this one, so meaning that 4 FBC, of course the proper way is you number it, number 1 and then number 2 into 1, right? This one becomes what, 68, right? So 68 if you bring to other side. So FBC becomes, how is this? 68 divided by 4, what do you get? 17, is it? This is in kilonewton. Right, so FBD, because it's the same, 17 kilonewton as well. Oh. Okay, this is this is what you have when you work from home, right? Anyway, but you, yeah, so my baby is down there. All right, so yeah, that's 17 kilonewton, 17 kilonewton. I think it's right at 17, 34, 68, right? Okay. Right, so after establishing this one, we can solve for all the forces using summation of force equal to 0 as per question number 1. Alright, so we have established this one. We just need this 2. This one is no longer needed, right? So we'll erase this one. Okay, so I'll use back the black one. So if you do summation of fx equal to 0, right? So you add all the x components. So ax, you have ax, and then this have x component, have x component, this doesn't have, right? So you have here plus 2 over 3 of 17, and then here minus 2 over 3 of 17 equal to 0. So we will have ax equal to 0, right? Because this cancel each other basically. Alright, so summation of fy equal to 0. So you have ay, and then this y component here minus 1 over 3 of 17, and then minus 1 over 3 of 17. This one doesn't have y component, this one doesn't have y component, this equal to 0. So ay will be, it's basically 34 over 3, right? Yeah, 34 over 3, or in the number 11.3 kilonewton. Right, and then we have summation of z equal to 0. So you have ez, you have this one z component, so plus 2 over 3 17 plus 2 over 3 17 okay, minus 3 minus 4 equal to 0, right? Okay, so we have z, 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 right? So from this calculation you can get your answer, right? So I believe if the calculation is correct, it will be minus 15.7 kilonewton. What does that minus mean? It means it is downwards, right? This az is downwards, so this is downwards. Is it clear in terms of the number there? Is it okay? Okay, alright, so that is basically how you calculate this problem, right? So I think if you have done several times this kind of question number 1, question number 2, and if you try something else, you'll notice that you actually improve in terms of the time you need to actually compute all of this, right? So that's where practice come into the picture, where you need enough practice to actually be able to solve this question in the optimum time, right? If you haven't got enough practice, if you do not practice enough, basically in the exam you will find that you will use too much time and you will not be able to solve all the questions needed, right? So hopefully you do practice enough, right? That is my advice. Take it if you want to succeed and to score good grades. Otherwise it's up to you. Alright, so going to the next question. Alright, so this is question number 3. So you can see the structure there on the left side, and then the question on the right says, determine the x and y components of reaction at the journal bearing A and the tension in chords BC and BD necessary for equilibrium of the rod shown in the figure. The concept is the same because this is still equilibrium of rigid bodies. So we have to know how to deal with the support reaction and then how to solve the equation of equilibrium, right? So first thing first, we draw the free body diagram. So it is basically something like this. So we have the rod, okay, something like that. So we have the forces, right? So we have forces, one force here going down. It's already given in the vector. So F1 minus 850 K Newton. And then we have F2 here. (420J) Newton, right? And then we have the two cable. FBC and FBD. So FBC and FBD. We have two cable there, and then we have support reaction at A. Okay, so the question says this is a journal bearing. So journal bearing meaning it doesn't prevent movement in y-axis in this case. So you can move freely in this case. So basically what do we have for, you have AX, of course. Oops. AX as well as MAX. Right? So for Y, you do not have AY because it's journal bearing. You do not have moment Y because it's free to rotate. For Z, you have AZ and also MAZ. Right, so if you are confused about how to get this, why is it like this for journal bearing, it is all explained in the lecture. So please go back and watch the lecture and understand the concept, why you have certain force and moment reaction. Yeah, right, so this is for journal bearing. It is important to understand and not memorize, because if you understand, then when it switch axis or the shape, etc., you understand what's going on, right? Okay, so we have established, and how many unknown we have? 1 2 3 4 5 6. Okay, the dimension is not given yet, so we have the dimension of, this is 6 meter. Oops. This is 2 meter, right? That's the dimension that we need. Okay, so of course, as usual, any forces that we need to express in terms of Cartesian vector form, in particular these two, we need to, right? Otherwise it will be very difficult to proceed with the calculation later on, right? So for FBC, so it is basically something like this. So from point B to point C. So from point B is what? 2 6 0, right? 2 6 0, and point C is 2 3 4, right? 2 3 4 upwards. All right, so RBC is 2 minus 2 is 0i, 3 minus 6 is minus 3j, 4 minus 0 is 4 plus 4k. RBC will be square root of those things, and you get 5, right? 3 4 5. And then UBC, you get 0i minus 3 over 5j plus 4 over 5k. And then FBC becomes 0i minus 3 over 5 FBCJ plus 4 over 5 FBCK. So you have expressed FBC in Cartesian vector form. Again, do the same for FB BD. Alright, so going there, BD. B is the same thing, 260. This one is 2 for point D, 2, 9, 4. So RBD, 2 minus 2, 0I, 9 minus 3 plus 3J plus 4K. RBD is 5. Then UBD, 0I plus 3 over 5J plus 4 over 5K. FBD is 0I plus 3 over 5 FBDJ plus 4 over 5 FBDK. Okay, so you have expressed, of course, because I'm doing this, and if you are also doing this in sequence, right, from question 1, question 2, question 3, it is testing your stamina, right? And you might notice that we are actually doing the same thing again and again and again, right? So that's basically it, actually, right? If you have done enough exercises, when you come to the exam, it's nothing new. You have done it multiple times, so it's just going through the same process, right? So it's not difficult, actually. If you face difficulty not knowing what to do, meaning you don't have enough exercises. Because if you have, it's just, I'm so bored, it's the same process again and again and again, and it's basically the same process again and again and again. All right. So having done this, what we have to solve is, because this is what do you call equilibrium problem. So we have, for equilibrium, so you need both to be satisfied. Summation of forces equal to 0 and summation of moment to 0. However, this is the first question that we have covered in this tutorial that is quite different, where you have moment reaction here, right? So in the previous question, when we deal with summation of moment, we don't have moment reaction here, so it's quite easy in that sense, right? In the sense that you only have to find forces, and there's no moment to make the equation have more unknown, right? So anyway, right, so is there any equation that we can solve straight away? Actually, there is. One is for AX, right, if you want to go in that direction. Do we want to? Let's do summation of moment first, right? And then it's clear. So let's just stick to the normal process, so that from there we can see what is known, what is unknown, and what can be solved, right? All right. So let's take again summation of moment about, this is point A, so point A equal to 0. Or, yeah. Okay, so basically, what this means is, because in this case is summation of R cross F, but also summation of couple moment there, right? So basically summation of R cross F plus summation of couple moment equal to 0, right? Basically summation of moment equal to 0, but in this case we have not only R cross F but also couple moment there, right? Okay, so okay, so so R cross F for this one, this one, this one, and this one, and then MC for this one, right? All right, nice. So what to do? Okay, so of course, if you, okay, how to do? Yeah. So if you do in terms of the matrix, right? Oops, is it already? Okay, I, GK. This is you can do the proper step one step before, right? So RAB cross this one, RAB cross this one, RAB cross this one, RA, there's no point here, RA something cross this one, for example. But this one doesn't, okay, this one doesn't produce any moment, right? Because it goes through the point. Okay, nice. Okay, so in this case, we'll do for RBC first, right? So IJK, and then for the RAC here, so this is 260, right? 260. And then the force of FBC is this one, right? So 0 minus 3 over 5 FBC minus 3 over 5 FBC 4 over 5 FBC. Right, so for R cross F for FBC, and then plus IJK. Okay, I'm taking too much space here. And then 260. And then this force here, right? So 0, 3 over 5 FBD, 4 over 5 FBD. And then plus another matrix for this one, F1. So IJK 260, the same point, and then 0, 0, minus 850. So this one settle, this one doesn't produce any moment, but this one doesn't produce, okay, and you have these two, right? So plus MAXI plus MAZK equal to 0. Right, so all there's all the R cross F and also couple moment that produce moment about point A. Right, so solving this one, so I'm using a different color perhaps. Oops. So for this first matrix here, so you have I 6 this is 24 over 5 24 over 5 FBC, right, and 0, and then minus J, so you have 8 over 5 FBC, right? And then for plus K, you have minus 6 over 5 FBC. Okay, that's the first matrix. The second matrix, plus I. For the second matrix, so this one, no, this one. So 24 over 5 FBC. Minus J, 8 over 5 FBD here, right? Oh, FBD, right? Plus K, so 6 over 5 FBD, right? Alright, what about this one? So plus I 6 times 850. What is 6 times 850? So let me check. It is because this is negative, right? So minus 5100, minus 5100. Right, so this one minus 0, and then minus J, this one becomes minus 1700, is it? And then plus K, you have 0 minus 0, right? And then you have this one, so plus MAXI Okay, no J here, but plus M E Z K here. All this equal to 0, right? All of this equal to 0. So the interesting part here, compared to previously, is that here you have 1, 2, 3 unknown. Here you have 2 unknown. Here you have 3 unknown, right? So the only thing that you can use is this one to just make how this FBC and FABD relate to each other, right? Because this one you cannot use it yet. Oops. Alright, so from there, okay, so if you take summation of moment about point y equal to 0, you have minus 8 over 5 FBC minus 8 over 5 FBD, basically plus 1700 equal to 0, right? So you can do something there, but it's not as helpful as before, right? Still, we can try to do something so that maybe it is helpful for the other equation, right? So for example here, because this is quite the same, so you can bring elsewhere, so you can get FBC plus FBD equal to, if you rearrange, this one becomes that one over there, you get 2125 over 2, is it? 2125 over 2. Verify the number, right? So basically, but if you rearrange this one, you get FBC plus FBD equal to this number, right? So that's this number 1. So let's just describe everything and see if we can use any of this, right? So sometimes it does require you to just explore and see how or what is possible in terms of simultaneous equation, right? Okay, now we have expressed my here, so let's just express the rest and see if we can use anything, right? So if you do summation of mx equal to 0, so it's this whole thing equal to 0, right? So you get 24 over 5 FBC plus 24 over 5 FBD minus 5100 plus MEX equal to 0, right? Okay, this one can be simplified in a way that 24 over 5 FBC plus FBD and then minus 5100 plus MEX equal to 0. So because this is already the same, right? FBC plus FBD is exactly FBC plus FBD here, right? If you can see. So if I name this question number 2, so if I plug in 1 into 2, you just plug in this one number into this one here, so we'll basically get 24 over 5 2125 over 2 minus 5100 plus MEX equal to 0. So I can actually calculate for MEX, right? If you calculate, it will be 0. Do verify the number, right? So do verify the number whether this is correct or not, right? So if you look at the force that produce moment about x-axis, right? So these are the all that is responsible, but because this is, if this is already cancelling each other, if this is cancelling each other, how do you guess that? Because if a moment about this one, this have to cancel each other, right? Because there's nothing else. So if this cancel each other, so obviously it the moment about this one is also cancelling each other. So it is logical, right? If you understand what I'm just said, right? Okay. What else? So if I express mz, right, summation of mz equal to 0, can we solve anything? So in this case, minus 6 over 5 FBC plus 6 over 5 FBD plus MEZ equal to 0. So we cannot do anything yet because this we cannot replace by this one, right? But at least we have several equations already. So my we already use it to plug in here. So we got this one already. This one we haven't used yet, right? So we have expressed all the three moments. So what is left is all the three forces, right? So we'll do that one. So if you just express each of the forces, summation of fx equal to 0, so we add all the x component, right? So here we have ax. This one doesn't have x component, doesn't have x component, doesn't have x component, doesn't have x component. So this one is straight away 0. Alright. And then summation of fy equal to 0. So no y here. This one is y, right? So we have 4 to 0. This one is from all the forces. Okay, I erased the forces just now, right? Okay, I expressed this one, but I erased the forces, so I don't remember the forces. So hopefully you still have in your paper, so you can refer back to. I have to refer back to my notes here. So what are the forces? For y, so this one you'll get minus 3 over 5 minus 3 over 5 FBC, and then plus 3 over 5 FBD, right? Yeah. This y component, no y component, this y component, right? Equal to 0. You can get FBC minus FBD equal to 700, right? Okay, so if you rearrange this, you get this one. So we'll see how it is applicable for something. So I forgot my numbers already, right? So this is 1, this is 2. Is there anything else? Let's say this is 3, right? I haven't simplified this enough, right? Actually, it can be simplified further. But anyway, this is 4, for example. Right, so from here and here we can solve actually, right? Something. For example, this and this. So if I do 1 plus 4, I mean this equation plus this equation, right? So you get 2 FBC, and then for FBD minus FBD is 0, equal to 700 plus 2125 over 2, right? So FBC you can solve here. Please check also the answer. So you get 881.25 Newton. Okay, verify the numbers. If you have this one already, so if you plug into any of into this one, right? So hence from 1 here, if you plug in FB here, what is this? FBC, sorry, FBC here, then you get FBD equal to, if you calculate, I believe 181.25 Newton there. What have we solved so far? FBC and FBD we have solved, right? Here MAX only, right? So the and AX also we have solved. What about this one? Okay, so this one, when we have already solved FBC and FBD, we can solve this one, right? So from number 3 we can have minus 6 over 5 FBC, which is 881.25, and then plus 5 over 6 over 5, 181.25, plus MAZ equal to 0. So MAZ equal to 840 Newton meter. Okay, what else is missing? Oh, FZ, right? So if I do summation of Fz equal to 0, you have Ez, and then this thing here, right, with Z component. So FBC, what is the I forgot already. So FBC is plus 4 over 5, so plus 4 over 5 FBC, which is FBC is 881.25, and then plus 5 over 4 over 5 FBD, which is 181.25, and then you have also this one, minus 850 minus 850 equal to 0, right? So you have Z component, Z component, Z component, and Z component. So if you do this, you get A Z equal to 0, right? Do verify all the numbers, right? So basically you have solved all, right? I believe 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, so that's the end of the question. It is quite interesting question to solve this one. Do try a question like this so that you know whether you are ready or not for this type of question where you have support reaction in terms of the moment, right? So with that said, moving on to the next question. Okay, this is question number 4. So you can see the diagram on the left and the question on the right there. So the signboard in the figure has a mass of 80 kilogram with center of mass at G. So in the diagram you have point G there. Determine the X, Y, Z component of reaction at ball and socket joint A and the tension in wire BC and BD. So this question is similar again from the at least question 1 and question 2 where you have the ball and socket and then you have two cables, right? So draw free body diagram first as usual. So if you draw the free body diagram, something like this, right? Oops, something like that roughly. So we have some, this is the rod there, right, where this is attached to basically the signboard here, right? Something like that. So it's the whole thing. So this whole thing is the body, right? So what do we have? So we have at point G you have a force downwards. That's one. And then you have another force from point B there and there, right? Two forces there roughly. And then you have support reaction at A. So this is ball and socket. So you have ball and socket, you will have AX, AY and AZ, right? So all the labels. So this one is known value, so 80 times 9.81 Newton. And then force FBC and FBD. So FBC, FBD. Right. Alright, so as usual, because this is quite straightforward, we just need to have this in Cartesian vector form, right, to help us, right? So for FBC, so if you have the 2 points there, so from point B to point C, from point B is 0 to 0, right? 0 to 0, I believe, right? 0 to 0, right? Yes. Point C is 1, 0, 2, right? 1, 0, 2. Okay. So RBC is 1I minus 2J plus 2K. RBC, the magnitude is square root, and then you get 489.3. So UBC, you'll get 1 over 3I minus 2 over 3J plus 2 over 3K. And then FBC, you get 1 over 3 FBCI minus 2 over 3 FBCJ plus 2 over 3 FBCK. Right. So for FBD, so it is something like that from point B to point D. Point B is the same point, 0 to 0. Point D is -2 negative 2, 0, 1, right? So RBD is minus 2i minus 2j plus 1k. RBD the magnitude, you square root, you get 3, right? UBD, you get minus 2 over 3i minus 2 over 3j plus 1 over 3k, and then FBD will be minus 2 over 3 FBDI minus 2 over 3 FBDJ plus 1 over 3 FBDK. Right. Okay, so that is described already. Now solving the equation of equilibrium, right? So for equilibrium, summation of forces equal to 0, summation of moment equal to 0 as well, right? Hopefully the color is still clear, right? Because the ink is almost at the end. Okay, as usual, okay, the free body diagram is missing the dimension here, right? Because we need the dimension. So basically this is 1 meter, this is 2 meter. This is not given, right? But the force, you can elongate upwards, so that's not necessary. Okay. So if you take moment about point A, summation of moment about point A equal to 0, right? And in this case it's R cross F everything, so summation of R cross F equal to 0, right? Incidentally, every diagram have A at the origin, right? Quite interesting. Okay. Okay, so R cross F. So we have R cross F for this one, and this one, right? So I, J, K. Let's start with this one, right? So we have X here, right? So 0 to 0, 0 to 0, and then FBC is this one, right? So 1 over 3 FBC minus 2 over 3 FBC plus 2 over 3 FBC. And then plus I, J, K, 0 to 0, and then you have this minus 2 over 3 FBD minus 2 over 3 FBD plus 1 over 3 FBD. Okay, not enough space again. Okay, so this one plus so here we have 0, 1, 0, right? Basically at this point here, 0, 1, 0, and then this one is minus, okay, what's the value there? If you calculate this one, what do you get? 80 times 9.81, 784.8 Newton. So that is 784 Newton. So you have here 0, 0 minus 784.8 Newton there. All of this equal to 0, right? Okay, so based on that, so solving one by one matrix. So so you have here 4 over 3 FBC, and then minus J 0, 0 plus K minus 2 over 3 FBC. Right, this one minus 0, okay, 0, 0, 0 minus 2 over 3. Okay, but this one plus I, so 2 over 3 FBD minus J, 0 minus 0 plus K, 0 minus minus minus, right, so become positive 4 over 3 FBD, right? And then what about this one? So plus I, minus 784.8 minus J, 0 minus 0 plus K, 0 minus 0, right? All of this equal to 0. Okay, so based on this, can we solve anything? Here we can equate FBC and FBD, right? And we can plug in here, right? Okay, I believe so. So if you do this one, because y is not useful because 0, 0, 0 is equal to 0, nothing there. So summation of z equal to 0 will have minus 2 over 3 FBC plus 4 over 3 FBD equal to 0. So basically if you arrange this, so FBC equal to 2 FBD, is it? Right? Okay. So, okay, where should I use the space? Okay, I'll erase this, but not until the end, right? Because I need the force there. Okay, bringing it here, summation of moment about x-axis equal to 0. So you have 4 over 3 FBC plus 2 over 3 FBD minus 784.8 equal to 0, right? So if you plug in there here, right, so 4 over 3 FBC equal to 2 FBD plus 2 over 3 FBD equal to 784.8. So how much is this? So this becomes 8 over 3, so 10 over 3 FBD equal to 784.8. So FBD equal to, if you calculate this one, what do you get? 235.44 Newton, right? 235.44 Newton. Okay, so if you already have established this one, then FBC is just, so FBC is just 2 times that, right? So 470.88 470.88 Newton. Alright, so you have already solved for these two. Right now is to solve for AX, AY, AZ using summation of forces. So if you do summation of Fx equal to 0, you have AX, and then you have component from these two, right? So for FBC, X component is 1 over 3 plus 1 over 3 FBC, which is this one, 470.88. And then for FBD, you have minus 2 over 3 times FBD. FBD is 235.44. Right? That's all about x-axis, right? Equal to 0. So you can calculate AX equal to 0. Right? So that's the answer there. summation of Fy equal to 0, Ay, and then you have minus 2 over 3 FBC, which is this one, 470.88, and then minus 2 over 3, this is, minus 2 over 3 FBD, which is 235.44. There's no other Y component, right? So equal to 0. So Ay equal to 470.88 Newton. Doing summation of Fz equal to 0, so you have Az, and then they have Z component here, here, and also here, right? So here plus 2 over 3 plus 2 over 3 FBC, which is 470.88, and then plus 1 over 3, this one times 235.44, and then minus this one, minus 784.8 equal to 0, right? So if you calculate, it should get 392.4 Newton, right? So then you have solved 1, 2, 3, 4, 5 unknown, right? So it does require some exercises. So this is I'm doing this. How many questions already? 4 questions hit back to back, right? So it's quite tiring, especially you are standing up like this, right? But that is the practice that when you do enough, you are quite prepared for any question, right? And you will see that the pattern is the same. You do free body diagram, you just establish Cartesian vector, and then summation of moment, summation of fx. Summation of moment do use moment about a point, right? So, right, going to the next question. So this is question 5, and on the left there you have the structure, and then on the right you have the question. Part A, it says, member AB is supported by a cable BC and at A by a square rod, which fits loosely through the square hole in the collar fixed to a member as shown. Determine the component of reaction at A and the tension in the cable needed to hold the rod in equilibrium. Part B. What would happen if the member AB is supported at A by a round rod which fits loosely through a round hole in the collar instead of the original square rod through a square hole? Will the structure be stable, and why? So part A is basically calculation based. Part B is if you understand, you can answer, right? Alright, so first thing first, draw the free body diagram as usual. So if we have x-axis like this, y and z like that, so we have something of a something like that, right? Okay, roughly something like that. And then we have the forces here, right? So here, okay, my axis is, my y-axis is, okay, we'll use my axis, right? So basically the axis is there, right? So this is 400 Newton. Okay, maybe I should use the axis that is quite similar as this, so it's not that slanted, right? Is it? So quite the same. Okay, so anyway, so that one, so 400 Newton, and then 200 Newton downward. And then we have, of course, the tension there. We can label it FBC. Yeah. Okay, so at A, because this is a collar and it's a square, right? So for AX, yes, you have AX, Oops. For AY, yes, you have AY. For AZ, no, because you are free to move. For MAX, yes, obviously. MAX, you cannot rotate about that one. MAY, you also cannot rotate about that one. MAZ, also you cannot rotate because it's square, right? Right, so with this, you have 5 support reaction there. And 1 here. In total 6, so you can solve. So this is 3 meter. Going down is 1 meter. That's the dimension needed, right? So that's the free body diagram. Hopefully you understand this one. If not, go back to the lecture which discuss in depth in terms of understanding this part, right? Okay, do we need to express anything in Cartesian vector? Yes, FBC, right? So for FBC, it is from point B to point C. Point B is 3, 0, minus 1, right? 3, 0, minus 1. Right. Point C is 0, 1.5, 0, right? Okay, so RBC is basically this minus 1, right? So minus 3I plus 1.5 J plus 1K. So RBC, the magnitude, what do you get if you have this number? 3.5. Okay, so then UBC, and you divide, so minus 6 over 7I plus 3 over 7J plus 2 over 7K. And then FBC is minus 6 over 7 FBCI plus 3 over 7 FBCJ plus 2 over 7 FBCK. So that is FBC in Cartesian vector form. Next, as usual, so for equilibrium, so we have summation of forces equal to 0, summation of moment equal to 0, right? So okay, so if we do summation of, okay, this is quite interesting because the only forces that are no, this is unknown, this is also unknown, right? Not only except for X, right? No, X is also not known, right? Except for Z, right? Yeah, the only thing that you can answer straight away is summation of Fz, I believe, right? But anyway, so if you do the standard way, so if you take moment, summation of moment about point A equal to 0, or in other words, summation of R cross F plus summation of moment, couple moment, must be equal to 0, right? About point A. So we have R cross F for this one, and this one, and then we have the couple moment here and here, right? So if you do the matrix for each of the R cross F for I, J, K, so we'll start with this one first. So X is here, right? So 3, 0, minus 1, right? 3, 0, minus 1, yes. And then the force is already here, right? So minus 6 over 7 F B C plus 3 over 7 F B C, 2 over 7 F B C. Okay, what about this one? 410, so plus I j k, it is 300, so 300, this is 400 to y, right? So 0, 400, 0. And then for the 200, so plus I j k 300, and then going down to 100, right? So 0, 0 minus 200. And then the couple moment, so you have max, so plus maxi plus mayj equal to 0. Sorry, you have maz also as well, right? Plus mazk equal to 0. So you have moment for this, moment for this, moment for this, moment, moment, and moment. Alright. So for this matrix here, I 0 minus become plus, so 3/7 FBC minus J, so 6/7 FBC, minus plus minus, okay, so minus 6/7 BC. Interesting. 6/7 as well, okay, plus K 9/7 FBC, right? Okay, for this one, plus I 0, 0 minus J 1, 1, 2, 0, 0, right? 1, 2, 0, 0 plus K, sorry, J is 0, right? Okay, what am I doing? Okay, so I'm hungry already, right? So J is 0, 0. For K is 1, 2, 0, 0 here, right? Okay, plus I for this one, so 0 minus J and minus J, yeah. So minus 600, 0, and then plus K 0, right? And then what else? So plus maxi plus mayj plus mazk to 0. Okay, by now I think you should have the idea why I always write like this, right? When I put from matrix here, because I can see straight away the equation and it helps a lot, right? So if you do mix up, so it's quite hard to follow when you want to check your calculation. So can we solve for anything? All will include simultaneous equation, right? This FBC and max, this oh wait, this one is 0, right? Then we can solve this one. Alright, so summation of y equal to 0. So because this minus this is 0 essentially, right? So 0, so you have 600 plus may equal to 0, so may equals to minus 600 Newton meter. Right. What does this 600 mean? It means it's clockwise, right? Meaning this may, it should be like that, clockwise. The actual answer, right? You can check whether it's logical or not, right? Because this force will produce rotation about this one, so it will counter that one, right? So generally speaking, okay. So that is may. Right. So the rest is simultaneous and simultaneous, right? So we'll do summation of forces first. So if you do summation of fx, Is there anything that is you can solve? Okay, we'll just write everything first, right? Summation of fx equal to 0. So basically you have ax over here. This is no x, no x. So this one is this one. So minus 6 over 7. FBC equal to 0, right? Okay. So what about summation of Fy? So you have AY plus 400 plus 3 over 7 FBC equal to 0. And then summation of Fz, you do not have AZ, you have minus 200 here, and then you have, oh okay, this one, plus 2 over 7 FBC equal to 0, is it? So this one should be solved first, and then you can solve everything else, right? Okay, so from here you can solve FBC equal to basically 700, is it 700 Newton. Okay, so FBC is 700 Newton. So having that already resolved, that means that you can solve for this one and this one, right? So from this equation here, actually AX you can solve. So if you calculate that one, so 700 becomes here, so becomes 600 Newton, right? And then you plug in here as well, so AY becomes, so 700 becomes here, so 300 plus 400 becomes 700, so minus 700 Newton. So meaning AY is a negative direction, is that way. Alright, what else? So one more that we haven't done is, because we have done AX, AY, FBC, right? And also MAY, so we have MAX yet. So summation of MZ equal to 0. So this is the equation here. So 9 over 7 FBC is 700 plus 1200 plus MEZ equal to 0, right? So MEZ equal to, so this is 900 plus 1200 minus 2100, is it? Let me check. Minus 29, okay. Have we solved MAX? Not yet, is it? Okay. So I'll lose count already what is we have solved and what we not. So how many have we solved? 1, 2, 3, 4, 5. Yes, we have 6. 1, 2, 3, 4, 5, 6. Right. So summation of x equal to 0. So you have this one, right? So 3 over 7, then 700 plus MEX equal to 0. So MEX equal to minus 300 Newton meter. So all of these are clockwise, right? Because it is negative, because we assume counterclockwise, or the thumb is in the positive direction, right? Okay, so that is the calculation part for this question over here. Part B. What would happen if the round member AB is supported at A by a round rod which fits loosely instead of the original square, right? So here we have the original square rod, right? So if we have a round collar, right? What is going to be different is this one, right? Because a round collar will allow for rotation about z-axis. This one comes into the picture because it is square, right? So you cannot rotate. So without this one, what will happen? Or if you just look at the diagram, without a restriction in terms of moment about z-axis, right? Then this will not be in equilibrium, right? Meaning without this one, right? Because especially from the diagram you can see this FBC, right, is creating a counterclockwise rotation about z, right? This one also create counterclockwise. There's nothing actually is countering that rotation except for this one, right? So if it's not there, if it's round, then from the diagram if you see, then it will just rotate. It will not be static, right? It will not be static. So insufficient support, right? All right. So that's part B. As long as you can explain that, you can secure that marks there, right? So moving on to the next question. Okay, this is question 6. So I'm not sure how long this video has been, but it will be quite long, right? Because it takes me several hours to record. It's more than 2 hours already, right? So anyway, so this is question 6. So we have the wing here. So the wing of the jet aircraft in the figure is subjected to a thrust T equal to 8 kilonewton. So you can see in the diagram there, from its engine, and the resultant lift force L equal to 54 kilonewton. You also can see in the diagram there. Don't worry if you don't even know what is lift, thrust, you can still just see the diagram and it's there. If the mass of the wing is 2 megagram and the mass center is at G, determine the XYZ component of reaction where the wing is fixed to the fuselage at A. Hint: for the free body diagram of the wing, the type of support at the wing A is mentioned in the question, right? So it already gives you the hint there so that you do not make a mistake in terms of drawing the free body diagram, right? So what is the hint? Because the question say the type of support at A is already mentioned, and what is mentioned is the wing is fixed, so it is a fixed support, right? So drawing the free body diagram first, right? So right, so you have the wing there, basically something like that, with the engine there intact, right? So we have several forces there. So one force is point G here, so it should be downwards like this, right? And then you have the thrust here, and then you have a lift here, right? So this is given 54 kilonewton. This is given as 8 kilonewton. Now in terms of the weight, right, we know it is 2 megagram. So 2 megagram is 2000 kilogram, right? 2000 kg. So times 9.81, this gives you 19620 Newton. But everything is in kilonewton, so 19.62 kilonewton, right? So 19.62 kilonewton, just to be consistent with the unit, so that when you calculate, you do not make any mistake. Okay, yeah, fixed support. So at A here, this is point A, right? So you have, I'll draw here. So you have AX, MAX, because it's fixed, so everything is there. So AY, MAY, AZ, MAZ. So all the 6 unknown is there, right? What else? You have the dimension there, right? So this is 5 meter. And then how to draw this? Okay, this is 3 meter, so in to scale, so this is 3.5 meter, and this one is 7 meter, is it? Alright, so is there anything need to be expressed in Cartesian vector form? In this question, then it's quite easy in the sense that there's no force that you need to express in Cartesian vector form, right? Because everything is either vertically down, vertically up, or horizontally down, meaning it's along any axis, right? So it's quite easy, it should be. Right, so in that case, can we solve straight away? So in this case, it should be straight away, right? So for equilibrium, summation of all forces equal to 0, summation of all moment equal to 0. Right. So what should we do first? I think this one quite straightforward for the forces, right? If you do summation of force in term x axis, so we have Ax and then plus 8, right? Kilonewton. Nothing else. So Ax equal to minus 8 kilonewton, right? So it is the negative direction. So summation of Fy equal to 0. So we have Ay and nothing else. This one equal to 0. Summation of Fz equal to 0. You have Az, and then you have minus 19.62. You have plus 54 equal to 0. So Az you can calculate to be, how to calculate this? You get minus 34.38, minus 34.38 kilonewton. So it will be downwards. Okay, so what about moment? So in question like this, for the moment you can choose to use vector or scalar, right? But because this is quite easy to use scalar, so I'm using scalar, right? So I'm showing using scalar. You can use use vector like r cos f as question before. The answer will be the same, right? So but I'm showing scalar because for the question before I always shown the vector because we have to use the vector. In this case we can use the scalar, so I'm showing the scalar, right? So if you do summation of moment but x-axis is equal to 0, okay. So it about x-axis here, so you have max about x-axis, right? So positive, this is positive. So this one producing negative direction, right? So minus 19.62 times distance of 5, right? This one is parallel, so not producing any moment about x. This one is producing counterclockwise, so positive, so plus 54 times distance of 7, 10, 15, right? Then you have, that's the only thing that produce moment about x, right? This and this. So from this one calculation, you should be able to calculate what is the answer there. Minus 711.9 kilonewton meter. What does that mean? Clockwise, right? If you do summation of moment about y equal to 0, y-axis, about this one, right? So obviously you have m-a-y there, and then this one on the axis not producing any moment, this one actually producing some moment about y, right? So it produce negative direction, right? So negative 8 times the distance of 3.5. This one goes through the axis, so not producing at the moment, so equal to 0. So MAY equal to positive something, right? So 28 kilonewton meter, right? Now, if any of you are confused about how to get this negative, where is it positive or negative, etc., if you are confused about that, go back to the chapter when we deal with scalar calculation, moment, etc. Or if you're still confused, just use the vector operation, r cos f, then all these numbers will come in automatically, right? Here you have to identify clockwise, counterclockwise, positive, negative, right? Summation of mz equal to 0. So this one, so we have maz. This one not producing a moment, parallel, this one producing negative direction, right? So minus 8, the distance of 8 to 0. So maz equal to 64 kilonewton meter. Yep. So again, if you are confused about positive and negative, if you are confused about distances, either you go back and refresh on that chapter, because all of these are using previous chapter, right? You are expected to know how to calculate moment, right? Or even if you understand but you still confused how to see the rotation, etc., maybe using vector can help, because using vector you just need the r cross f, right? So that should be more straightforward for some student. Alright, so that is the question number 6. So we'll go to the next question. Okay, so this is question number 7. This is the last question of the day of this tutorial. So we have the curve rod in the left there in the diagram, and then we have this question, part C and D. The curve rod in the figure lies in the XY plane and has a radius of 3 meters. If a force F equal to 80 Newton X at its end as shown, determine the support reaction at the fixed end O, right? So we need to find what is the support reaction at O. And then part D, if the fixed end O is replaced by a ball and socket support, what will happen and why? Right, so part D is an understanding question. We will solve this question. Similar step, free body diagram, express Cartesian vector if needed, and then solve equation of equilibrium. No. Okay, I'm just trying to draw as accurate as I can. Alright. So it's something like that, right? So we have a curve rod there, right? Something like that. And then we have the force, something like that, F equal to 80 Newton. Okay, so the curve rod, the question says determine the reaction support at the fixed end. So meaning that this is fixed support. So we will have AX, MAX, AY, MAY, AZ, MEZ. Right? So fixed support have every single, wait, why is it blurring? Okay, why is it failing to focus? Okay, hopefully. So what we have just said is that this fixed support have all the AX, AY, AZ and MAX, MAY, MEZ. I'm not sure why this is blurring. I hope I didn't miss any part that is blurred and you cannot see, right? Okay. What else? So we have the dimension. So we have 3 meter and 3 meter, right? So this is 3 meter and 3 meter. Right. Okay, so that is the free body diagram there. So what is needed in terms of Cartesian vector form is this force here, right? 18 Newton here. We need in terms of Cartesian vector form. So for FAC here, right? So yeah, basically force from A to C, right? So we have point A to point C, right? So point A is 330. Point C is 4, 0, minus 2. Right, 3, 3, 0, 4, 0, minus 2. Okay, so R A is not is A. AC is this minus that one. Right? So 1I. Wait, this minus that one. Right? So minus 3J. Minus 2K. So RAC in terms of the magnitude, when you square root everything, so what do we have? 9 plus 4 is 13, 14. Square root of 14, is it? Then it's some point, it's decimal point. Okay, square root of 14. So I'm using this one. So UAC is 1 over square root of 14I minus 3 over square root of 14J minus 2 over square root of 14K. Right? So F is simply this 80 Newton times the whole thing, right? So 80 over square root of 14I minus 240 over square root of 14J minus 160 over square root of 14K. Okay, is the lighting bad? Hopefully you can still see this part at least, or the whiteboard at least. Right, so that's the force. Right, so the rest is just calculation using equation of equilibrium, right? So because when fixed, so you will notice from the previous question and this question, when it is fixed, normally in terms of solving the equation of equilibrium will become straightforward, because you will not see any simultaneous equation, because everything is force x, force y, force z, and moment x, moment y, moment z. So everything have its own equation. So the solution becomes simple. That's why you don't see fixed support that much in the exam, because we want to make it not as simple as for you, right? Unfortunately. But if you are lucky, like in this semester, it becomes simple because fixed support, meaning everything is there. And then, as you can see, just like in question number 6 before, or this question, it will be so straightforward. Alright, so for equilibrium, so summation of all forces equal to 0, summation of all moment equal to 0, right? So if you do summation of Fx equal to 0, so of course you have Ex, nothing else except this force, right? So in this case, plus 80 over square root of 14 equal to 0, right? So basically Ex is minus this one, right? So you can get minus 21.38 kilonewton. Is it kilonewton? No, Newton. Boom, the answer. Summation of Fy equal to 0. So you have Ay plus this y, right? So it become minus 240 over square root of 14 equal to 0. So Ay equal to positive something, right? 64.14 Newton. Boom, another answer. So that's just to motivate you to go forward, right? Okay, summation of Fz equal to 0. So you have Ez from here, and then this one, minus 160 over square root of 14 equal to 0. So Ez equal to positive something, right? So 42.76 Newton. Alright, what is left is just the moment. Okay, how to deal with the moment? So, okay, In the previous question, we have shown a scalar. So right now, I'm showing vector, right? Both way can be solved, but right now I'm showing vector. So if you do r cross f for this one, you get the equation then straight away, right? So for summation of moment, so if you do, is there enough space? Okay, so you have already this answer, right? So ax, ay, az already solved. So I erase this one. I want to use the space. So if you use vector, so summation of moment about point, what is this, a, equal to 0 is basically summation of r cos f plus summation of couple moment to 0, right? So r cos f is only for this one, couple moment, right? So r cos f, so we have I, j, k. R is from here to here is 330, right? 330, and then plug in this straight away, right? 80 over square root of 14 minus 240 over square root of 14 minus 160 over square root of 14, right? You might notice that I have a habit of keep this kind of number until the end, right? Because that will meaning my error here is still 0 because I haven't introduced any error. If you already change into decimal point here, normally you will cut off something, then you already introduce error, and then when you multiply, the error can become big and big and big. So I do like to avoid that, right? So you just keep it like this until in the end we just round off, right? Okay, this is for r cross f, right? And then there's nothing else except for plus maxi plus mayj plus mazk equal to 0, right? So solving I this one, right? So what, 3480 minus 480 over square root of 14, is it? And then minus j, this one, right? So it's still minus 480 over square root of 14, right? And then plus k, this and this, right? So what will this become? 6720, is it? Minus 720 over square root of 14. Kenapa? Minus 240 over square root of 14. Kenapa? Okay, so what, I don't know what just happened just now. Okay, so I think that is this, if there's no mistake here. So and then plus maxi plus mayj plus mazk, all of this equal to 0, right? So from here you can solve straight away, right? You can see that already. Oh, I can solve max, my, and maz. So then summation of mx equal to 0, which means this one, minus 480 over square root of 14 plus max equal to 0. All of these are calculation method, right? So please do not skip steps, otherwise it creates suspicion whether copy from somewhere or something, right? So so m vx equal to, so it will be positive something, right? 480 divided by square root of 14 becomes 128.29 Newton meter, right? Okay, summation of my equal to 0, so we'll have this one. If you can see, it's basically the same, right? Except for the sign. So because here you get 480 over square root of 14, where is it? Plus may equal to 0. So of course may become the negative of this same answer here, right? And then maz, I think you know the drill already, so I'm just writing the answer. So you do summation of mz equal to 0, then you have this plus this equal to 0. So you should be able to get MAZ equal to 256.57 Newton meter. Right, another positive answer. Right, so basically you have solved for all the 6 unknown, right? 1, 2, 3, 4, 5, 6 unknown. Right, so there you go. This is if you use cross product for scalar calculation, right? If you use vector, this is vector operation. Yeah, so I'm so hungry already that I cannot think straight. But anyway, so this is the last part. The question is not finished because there's part D there. If the fixed and O is replaced by ball and socket, what will happen? Can you think of it? What will happen? So if you refer to this free body diagram, if O is ball and socket, then you will not have all of this moment, right? So this one, and this one will not be there. And calculation wise, if there's no MAX, MAY, MAZ, meaning there's no this thing, it's impossible to get moment equal to 0, right? For example, if this is not existent, so this one cannot be equal to 0. Impossible. This one cannot equal to 0. This one cannot equal to 0, meaning that summation of moment cannot be equal to 0, meaning that it will not be static. It will basically just fall down, right? So from logically, I think you can see if you look back at the diagram, because now it's like that, and then the curve that is like that, it's still like that because this is fixed. But if this is okay, my kid. Okay, if it's ball and socket, it will just fall down like that, right? So that will be what happened. The support is not sufficient to make it static, right? So yeah, there you go. As long as you can explain that, you will secure that mark, right? All right, so that is all the 7 question, right? The 7 question, it has been long. If you actually watch from the beginning until the end, it will be long, and trust me, it's actually longer to record this whole thing, and not to account that the preparation before and the editing after and then the uploading, etc., right? So it is taking quite a long time to, it's already 11. I started at 8, so it's already 11, so it's 3 hours to record this alone. I'm not sure what is the final the final duration, because it should be shorter because I will cut and etc., right? Anyway, so there you go. So the purpose of I'm doing this is that I'm giving the chance for you to at least go through the tutorial of enough example, or this is actually all the question, equilibrium of rigid body question in 3D that have been in the exam question in the past several years, right? So you get to know different type of question that can come up, different type of difficulties, different approach that can be used, different approach that is needed to be used, etc., right? So it is for you to appreciate these aspects, right? It's up to you actually to cover all of the question or not, right? Because some will say, but the tutorial session is just this hours, right? So why should I cover all? It's up to you actually to cover or not to cover. This is just to make it available for anyone who need to practice, right? So you have it. If you do not want to utilize, it's up to you. The consequences is up to each of us, right? So we choose what we want to do. We live with the consequences, right? It's not other people's fault if you do not understand, if you do not try, right? So it's on us, right? So from my perspective, that's just my duty to give it available for anyone who need it, right? So if you don't think you need it, up to you. If you don't want it, it's up to you as well, right? So with that said, hopefully if there's any question still, either there's any mistake or there's something that I explained that is not clear, except for those who I did mention. The explanation of certain concept is in the lecture video or in the previous tutorial if it's based on previous chapter, right? Chapter 4, for example. Make sure you go back there, right? Because it is expected that you have covered those things, understand those things, and come to this chapter, right? It's hopefully you understand that concept, right? So yes, for some of us, we do need to have extra effort to cover for whatever we have not solidly understood before, right? So that's life, so you cannot complain about anything, because some students actually have spent the time before to understand that, so they are the advantage, they have understood the basic now and they can move forward. For us that did not spend the time back then, we have to spend the time now, right? So it's that's life. We have to just live with it, right? And take the necessary action. Do not delay. If you do delay, oh, I don't understand, maybe I will try to find some time later. You delay, next chapter, it will be beyond what you can handle, right? So take the action now, revise, etc, etc. Alright, so with that said, do like the video if this have been helpful in any way in terms of making you understand, inshallah, or prepare. Appreciate the support, inshallah. And with that, we end. Subhanakallahumma bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.